Question 1 is asking for the slope of the tangent line, which we know that comes from the derivative. So let's start there. Y prime or dy dx equals. So we use the chain rule. The derivative of natural log is 1 over whatever's on the inside. And the chain rule says let's multiply that by the derivative of the inside, which is -1. So they want the slope at -1. I guess I could have just put that up there. And so I have a -1/2. Question 2 is straight up asking for a derivative. And when I look at this, I see a product. So we're going to use the product rule. So I have the first. The derivative of the second is e to the x plus 0. Plus the second, which I need parentheses here around that binomial, times the derivative of the first, which is 2x. So there is my derivative, but as I look at all of these answers, I realize they don't have parentheses, so we probably should do a little bit of cleanup here. So x squared e to the x, fine, plus 2x e to the x minus 2x. And I think that's letter C. So question 3, we've seen lots of these this year, but we have a table, lots of information. They're introducing f and g and their derivatives. But then they start talking about h, and essentially they want h prime of 1, which means the first thing we need to find is h prime of x. Now, h of x is a composition. Chain rule says start on the outside. There's my biggest set of parentheses. On the outside is f. The derivative of f is f prime. We leave the inside alone. So it says f prime of g of x. The chain rule says now multiply that whole thing by the derivative of the inside, which is g prime of x. So there's my first derivative. They want us to go plug in a 1. So I have f prime of g of 1 times g prime of 1. And we can start working backwards. It doesn't really matter. I need g prime of 1. G prime at 1 is 2. Now, this says g of 1. G of 1 is -1. So I'm going to replace that inside with a -1, meaning I want f prime of -1, which is 5. And 5 times 2 is 10. Good. Speaking of the chain rule, let's take a look at question number 4. Again, a straightforward derivative question. They're giving us a function. They want f prime. Now, before I start, I'm going to rewrite this as we should, mathematically more meaningful. Cosine cubed of 4t means the cosine of 4t cubed. That's a big deal because that's going to tell us where to start with the chain rule. We're going to bring that 3 down in front and we are going to subtract 1 from the exponent. So I have 3 times the cosine of 4t squared. Okay. The chain rule says now we need to multiply by the derivative of the inside, which is another chain rule. We're going to start on the outside. The derivative of cosine is negative sine of 4t. And then we need to finish by multiplying that whole thing by 4. All right, so I have a negative, which means I can already rule out a and d, but I have a -12 cosine squared of 4t sine of 4t, which is letter B. Good. 5 is doing the same thing. Just take the derivative. Chain rule again. I'm going to start on the outside. Oh, this is something we need to have memorized. The derivative of inverse sine is 1 over the square root of 1 minus blank squared. So again, I'm kind of looking at it going, I think I can rule out letter A because I don't see that. That's okay. We don't want to get hasty though in case, okay. The inside is 5x. I'm going to put a 5x in there. But don't forget the chain rule that says multiply that whole thing by 5. So I think if we square that and call that 25x squared, I think we're looking at letter D. All right. Let's flip it over and take a look at number 6. Whoops, way up here. All right, so really what we're looking at is find an equation for the tangent line when x equals 1. We kind of looked at that in like a previous section of this packet. So if we want to write the equation of a tangent line, we need a point, which they gave us the x-coordinate, and we need the slope. Great, let's finish the point. We need the y-coordinate. So I'm going to go back to the equation for y, and if I plug in a 1, I get 1 to the 5th, which is 1, and 1 wasn't 2, so I get a y value of 2. Slope comes from the derivative. Oh, we get to use the product rule. I'll come over here. So here we go. I've got the first, which is 2x minus 1 to the 5th, times the derivative of the second, which is 1, plus the second, which is x plus 1, times the derivative of the first, which is chain rule. All right, so here we go. We're going to bring that 5 down in front, leave the inside alone, subtract 1 from the exponent, and don't forget to multiply that piece by 2. Great, so there's my derivative. I want the slope when x equals 1. So I'm going to go plug a 1 in for every x, which again is going to give us similar things. So I get 1 to the 5th, which is 1, plus, I'm going to bring that 2 out in front. 1 plus 1 is 2. I got that 5. We still said this is 1, and 1 to the 4th is 1. So let's see, I have 1 plus 20, which is 21. So that's going to rule out these three, right? Because we're looking at y equals mx plus b. So when I write my line, I'm going to start with point slope form, and then I'm going to clean it up. So I distributed my 21, and I'm going to move the 2 to the other side, which is where my minus 19 comes from. Good. All right, so question 7, again, very similar to what we saw in the front. It's just find the derivative. Okay, but what's different here is that my equation has x's and y's in it. It doesn't say y equals. That's okay. We're just going to start taking the derivative of everything. Let's see, the derivative of 3x is 3, minus, we're going to use a chain rule here. The derivative of the tangent of y is secant squared of y dy dx. Then I go to the other side of the equal sign and I get a big fat 0. We're trying to find dy dx. So let's add this to the other side just to keep the negatives out of there. And then I'm going to divide by secant squared. So dy dx equals 3 divided by secant squared of y. Well, we know dividing by secant is the same as multiplying by cosine, and so that's where we would get letter B. Just renaming it. Good, so kind of like a very simple version of an implicit differentiation question. Good. So let's take a look at number 8. Now, number 8 is something we have been seeing in our multiple choice, or I'm sorry, our free response packets in class. Essentially, we can talk about why that's there, but it's really there for a domain issue. They're asking us to take the derivative of this. This is the fundamental theorem of calculus part 1. They told us how to take the derivative of an integral. Remember, integral means antiderivative. So we're taking the derivative of the antiderivative, which is kind of crazy because it undoes each other. So the rule was make sure your variable's in the upper bound, which it is, and go plug it in for every t. So I have a 1 over 1 plus blank squared. That's what was in my integrand. I'm going to replace the t with a radical x. Now we're not done. That's a big first step. The chain rule says multiply by the derivative of your upper bound. So if this is x to the 1/2, the derivative is 1/2 x to the negative 1/2. And we're just going to clean it up until we see our answer. So I'm really left with a 1 over 1 plus x, and then I have a 1/2 and a radical x in the bottom. So I think we're looking at letter A. Good. All right, let's take a look at number 9. So they're talking about the graph of f, the equation for g. Okay. They want the value for g prime of 2. All right, so let's come back and see what we're going to use that for, but let's focus on this. If they want g prime of 2, the first thing we need is g prime of x. Oh, g of x is a quotient, so to take the derivative, I am going to use the quotient rule. Quotient rule says square the bottom, and then we're going to rewrite the bottom, and then we're going to multiply by the derivative of the top, which is just 2x. Like, I don't need parentheses. You can put them there. Minus the top, now I do need parentheses because I have more than one term, times the derivative of the bottom, which is f prime of x. All right, so we're ready to go plug a 2 in for every x. So I have f of 2 times, well, that's going to be a 4 now, minus, if I put a 2 in here, I get a 5 times f prime of 2 all over f of 2 squared. I mean, I could have found some of these things along the way, but I just thought we'd wait. All right, so f of 2 says find the y value on f at 2. Oh, here's f, and the y value there is 3. So right now I have a 12 minus 5 times something all over 3 squared, right? We needed to find f of 2 twice, so okay. The last thing I need is f prime of 2. F prime of 2 wants the slope on f when x equals 2. Well, good thing it's linear. Let's see, it looks like going up 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. Yeah, it's linear. 1, 2, 3. So the slope is 4. And so what do we have? 12 minus 20 is negative 8 over 9, which is letter A.